Question number 10 of the 2012 Fall Exam 2 states, a parallel plate capacitor is connected to an ideal battery with terminal voltage V. While still connected to the battery, the parallel plates are pulled apart until the distance between them doubles. Given the initial values of potential energy U, electric field energy density UE, and charge separation Q, what are the final values of these quantities? Our first step in solving this problem is identifying the given information. While the battery is still attached to the capacitor, the potential difference over the circuit V remains the same. They also give us that the initial distance is half that, between the capacitors, is half that of the final distance. First thing we do with this information is figure out the new capacitance. Because capacitance varies inversely with the distance between the plates, we can see that plugging in 1/2 D for, or 2D for here, we get the final capacitance is equal to half that of the initial. We can use this to figure out potential energy stored in this system. Potential energy U equals 1/2 CV squared. Because V squared is going to remain the same, we can simply plug in the 1/2 of the original capacitance, and we get that the final potential energy is 1/2 that of the initial potential energy. For our next step, we're going to need to find the electric field in between the capacitors. This is given by the relationship voltage over distance. Again, plugging in the new distance between the capacitors, we are given that the final distance, the final electric field is equal to half that of the original electric field. We also have the equation that the energy field density, UE, is equal to 1/2 epsilon naught E squared. Because this is a squared relationship, when we plug in the 1/2, we are given that the final electric field density is equal to 1/4 of the initial electric field density. In order to figure out the last bit, we know that the charge separation Q is equal to the capacitance times the voltage. This also depends linearly on the capacitance, so plugging in the fact that the final capacitance is half that of the initial capacitance, we get that the final charge separation is half that of the original. Taking these three data points, we can find that D is the right answer.